Oh, so today I'll be doing what I did in the previous video, but with squares. So here's what I mean. I want to find a formula that, so if I'm given the final term, or at least like how many terms there are, I can find the sum. So let's say if there's 7 terms, or n equals 7, then that would be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 7 squared equals some number. The S just stands for sum. I want to find S in terms of n. So like if I plug in 7 into some formula, I got S. And here's how to do it. So first of all, I'm going to try to prove this. This combination of sums equals this one sum here. So let's say n equal 1. Then 1 cubed is 1, this is 3, this is 3, this is 1. And look, this is just 1 plus 1 cubed. 1 plus 3 is 4, plus 3 is 7, plus 1 is 8. And 2 to the cubed is also 8. Let's see for n equal 2. This would be 8, this would be 12, this would be 6, this would be 1 again. And then this would be plus 2 plus 1 cubed. Now if we sum all of these, this is n equal 2. We also have to take into account this. So 9 plus 15 is 24, plus 9 is, 31, and plus 2 is 33. So this should also equal 33. 8 plus 27, oh shoot, never mind, 35. Let me redo it. 20, 26, 27, 28, 31, 34, 30, yeah. These 4 numbers, or these 8 numbers, also equal 35. So we know this to be true. Now what I want to find is, if that is so, what's this? Well, if this equals that, we can just expand it to get this. 3i, we can factor that out. Minus, because I'm subtracting that from that. And then finally we get an answer of and this here is what we want. Okay, but this also equals something else. If you watch my previous video, you probably know what I'm gonna do next. So this, let me just not be lazy anymore and write down the things I'm supposed to write down. Plus 1 cubed and n sum equal 1 I cubed. So this would equal sum 1 cubed plus, oh no, starts from 2. If we plug in 1, this means I starts at 1. So if we plug in 1, that's 1 plus 1 cubed, that's 2 cubed. That means the second term, we plug in 2. 2 plus 1 is 3. 3 cubed plus 4 cubed plus dot dot dot, and so on, n cubed plus, in the final term. And the thing on the top of the sigma symbol denotes the final term, and that's n. So we plug in n here as an I, we get n plus 1 cubed. This equals, well, 1 cubed. This is always going to be 1 behind this one. So 2 cubed plus 3 cubed plus 4 cubed, dot dot, plus, and the final term of this is just n, so it's just n cubed. Now when we subtract this, this is what we get. This cancels out, 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 and finally that cancels out. So we get that this thing right here this also equals this, or sorry, this minus 1. And I'm going to factor it out, or I'll just leave it unfactored for now. Minus 1. Now, look here. We know this equals 2 things. This equals this right here, and this also equals that right there. So we can set these two to equal each other. So now I'm going to factor it out. 3n squared plus 3n plus 1 equals remember, I'm copying this right here. Sum of 1, and from the previous video, we know what the sum of this just means, or remember, this is shorthand, this is not correct notation, this is correct notation, and that just stands for, this is an I, by the way, but plus 2 plus 3 plus n, and this just equals, as we discovered in the previous video, that. Now, the sum of 1, as we also discovered in the previous video, just equals n. So if we, rewrite things around, and let's multiply by 2 everything, 2 to everything, so we can get rid of this nasty 2 here. So 2n cubed plus 6n squared plus 6n plus 2 equal 6i squared, and 2, n squared plus n. So if we distribute 3 to everything, 3n squared times 3n, 3n squared plus 3n. Remember, I removed the 2 because I multiplied everything by 2, so we can remove it. And then finally, just 2n. And we're trying to find this thing right here. So let's make this all go to one side. Hold on, let me see. So 2n cubed would remain the same. 3n squared would be reduced by 3. 6n, this is n. Oh, I'm sorry. I forgot this subtract 1 symbol here. So it should be 2 minus 2, because I multiplied everything by 2. So see, if we do this, so these things should have canceled out beforehand, and if we double everything, then we should have, yeah. So there shouldn't be a 1 here. I'm sorry about that. Yeah, I should have wrote that over here. And then when I doubled everything, this would become in 2, and this would become negative 2, and they would cancel out either way. So we get this. Finally, we get the final answer as and yeah, that's it. Now, I'm going to do the same thing, but for this formula. And this is just 1 cubed plus 2 cubed plus 3 cubed, plus n cubed. So I'm just going to do the same method, but I'm just going to make the power higher. So we get, I'll be untalkative for a while. So just stay put. Let me think here. This would be the sum of, I'm going to use Pascal's triangle. 1, 4, 6, 4, 1. So this would be 4 I cubed, I think, plus 6 I squared plus 4 I plus the sum of 1. This entire thing would equal well, it's just n plus 1 to the 4th minus 1. Let's do this on another page. I'm going to rip this up so I can use it as a reference. Now that we have that, we can factor this out. We get that, let's just, so that's n, that's n squared over n plus 2 plus n over 2, and that's what we just found, which is somewhere over here, yeah. So let's, yeah, 4 cubed plus 6 2n cubed. Luckily, there's a 6 over there, so 6 distributes to everything over here. 3n squared, I'll move it here, plus, and well, actually, you need to be able to see where I'm getting the formula from. Just basically expanding all of these, all right? Plus n, and then finally 4 times, then that would be 2n squared plus 2n, because I just equals n squared plus n over 2. If you multiply by 4, it's just 2n squared plus 2n. And finally, the sigma 1 is just n equals n to the 4th plus 4n cubed plus 6n squared plus 4n plus 1 minus 1. The 1's cancel out. Let's move everything to this one side so we can find this. And the 4th will remain the same. 4n cubed minus 2n cubed plus 2n cubed. 6n squared minus 5n squared plus n squared, I think. Yeah. And then 4n minus 4n. Oh, the 4n's just cancel out and this cancels out. So we get our final formula as this. So let me just write down. This will be very important for my next video for you to understand this. So I'm going to talk about the integrals of polynomials next video. And I want you to notice something here. So we have 2n cubed plus 3n squared plus n over 6. And the sum of I is just n squared plus n. What I want you to notice is the one with the largest degree. If we separate it from the group, we just get, like if we just separate it from the group, we get n4 over 4. And this one is just 2n cubed over 6. And this is n squared over 2. Now look, this just simplifies down to n cubed over 3. The funny thing here is that the power also equals the denominator of the fraction. So n cubed is 3. And then I bet I can predict that the largest power would be n5 over 5. But this is not the formula for that. But I'm just saying if we, take the largest power out, it would be that I5 and likewise for I6. And you can find this reasoning for yourself because of Pascal's triangle. 1, 3, 3, 1, 1, 4, 6, 4, 1. Because if you look here, basically we divide this number. This number is going to be this, 1, 5, this. It's going to be continually ascending. So if we divide 4, and then we divide 4 by this is being divided by 4, the one with the highest power. But the one with the highest power will always be 1, 1, 1, 1. And I really don't know how to explain this, but you can just look in the past that this always had that number because of Pascal's triangle. See, look here. Yeah, all right, it's hard to explain. So for I squared, it would be 3 because on Pascal's triangle, 3 is here. But for the next one, the next power, 4. And yeah, I really don't know how to explain this, but just know that if you can prove this using Pascal's triangle, that the highest power of the sum will always have the denominator equal to its power. Thank you.